So in 1.3, we're going to discuss more about functions and their graphs. The objectives are to identify when you have an increasing, decreasing, or a constant function, to locate relative maxima or minima, test for symmetry, identify if you have an even or odd function, or recognize their symmetries, understand and use piecewise functions, and then find and simplify what's called a function's difference quotient. So we're going to start here, and we're going to fill in the blanks. And it says here, so this is our definition. A function is increasing on an open interval I if f at x sub 1 is less than f of x sub 2, whenever x sub 1 is less than x sub 2 for any x sub 1 and x sub 2 in the interval. So that seems really wordy. What do they mean by that? What are all these symbols in here? So let's talk about what this first statement here means. So what we're going to do is let's look at if we had this XY plane. And so here is our horizontal axis. Here's our y-axis. Now remember, the horizontal axis is the input and the y is the output. And we learned that y, if you have a function, you can, instead of writing y here, you can call this f of x. So let's figure out what they're saying here. I have 2 points. I have x1, x2. And it says that x1 is less than x2. Well, that means that x1 has to be to the left of x2 on the number line. In order for a number to be less than, it has to be to the left of the other one on the number line. So this is our setup so far. And it says if the function output of f sub 1 is less than the function output of f sub 2. So in order for this to be true, if on the vertical axis, f sub 1 has to be below f sub 2 on a vertical axis in order for it to be less than. So it is saying that you've got an ordered pair here, x sub 1, and then the output. And you've got an ordered pair here, x sub 2, and its output. If the output of the first input is less than the output of the second input, then the function is increasing. So you're going to see the line will go up. The line will go upwards from left to right. Now, our next sentence here, number 2, a function is decreasing on an open interval. So open interval I, you've got the first point is less than the second point, x sub 1 is less than x sub 2. So this is the same here, but f of x sub 1 is greater than f of x sub 2. So that means, let's erase this, that f sub 1 would be up here and f sub 2 would be below it. If f sub 1 is greater than on the y-axis, then it has to be above f sub 2. So let's line up those ordered pairs. X sub 1 f of x sub 1, x sub 2, f of x sub 2. So when you connect the 2 points, they go downward. So we're going to say, if that's the case, decreasing lines will go downward from left to right. And the third case is if a function is constant. If a function is constant, on an open interval I, then the outputs are equal for any x sub 1 and x sub 2 on the interval. So that means they don't even tell us which one is less than. But if the outputs are constant or equal, meaning they're at the same part. So this here means there's the same output. So here and here. That creates a horizontal line. And so the line will remain the same. It doesn't go up and it doesn't go down. So it will remain the same from left to right. All right, so now let's take these definitions and let's see if we can apply it to this function that we're given. We want to state the intervals on which the given function is increasing, decreasing, or constant. So I'm going to look for increasing first. So increasing, when I'm looking at this, I want to look at where the function is going upward from left to right. And I'm just going to draw right on here. I see it going up from here. And then I see it makes a turn. So right about here, it makes a turn. And then it goes downward. And when it goes downward from left to right, that's considered decreasing. And then I see it stops here going downward, and then it goes back to increasing. So another what is called a turning point. When it changes from going up to down, it's called a turning point. So we can see that we have a part that's increasing, we have a part that's decreasing, and then we have a part that's increasing. So I'm going to read it from left to right. And when I want to state the intervals, that means I want my answer in what's called interval notation. And we saw a little bit of this in the previous section. And in order to state your answers in interval notation, you are going to, first of all, read the x-axis. So we're not even going to look at the y-axis. We are reading the x-axis to tell what intervals. And I see from here, that turning point, and below, it's increasing. And from this turning point and above, it is increasing. And it decreases in between those two turning points. So in this little blue region. And this is my number line. And remember, your number line goes from negative infinity to positive infinity. And in order to write something in interval notation, we're going to put the smaller endpoint on the left-hand side. We're going to put the larger endpoint on the right-hand side. We're going to separate the two endpoints with a comma. Then we choose a parenthesis or a bracket based on whether the endpoint is included or excluded. So a parenthesis means it's excluded, or what's called an open interval. And a bracket means that it is the endpoint is included, or called a closed interval. And you can have a mixture. You can have the same bracket and parenthesis on both sides, or you can have a mixture. So this is interval notation. Now, increasing. Remember, you are reading the x-axis to give the intervals. Now, for increasing, I see there's two parts, the ones I highlighted in yellow. The smaller endpoint is negative infinity. The larger endpoint is -1. So we're talking about any number smaller than -1 is an increasing interval. Infinity, whether it's negative or positive, will have an open interval. And -1, that's the turning point. So it's not included in the increasing or the decreasing. So we call it an open interval. So this right here, and whenever you use negative infinity, it's always the concept of the smaller endpoint. So it's always on the left. This right here means any number smaller than -1. And then from here to the right, that's from 1. So read the x-axis. 1 is the turning point to positive infinity. And I'm putting parentheses on both sides because, again, the turning point is not included in the decreasing or increasing. It's kind of by itself. And the infinity is always open-ended. So this means numbers larger than +1. And we can say this, it's increasing. The union just means and both of those pieces. Now, to tell the reader where it's decreasing, we're going to read this little blue section. And so the smaller endpoint would be -1. The larger endpoint is +1. And both of these, remember, the turning point's not included, so we're going to use parentheses. And so this is the numbers that fall between -1 and 1. So what I'm writing out is the wording or the description of that interval notation. So we've got increasing, we've got decreasing. Constant, there is nothing constant here, so we don't have to write anything. Now, at these turning points, you have a relative maxima or minimum. So filling in the blanks here, a function value is a relative maximum of f if there exists an open interval containing a such that f of a is greater than f of x for all x not equal to a. Again, this is the formal definition. This is the output at a greater than the outputs of x. And for the second part, you have a relative minimum if there is an open interval containing b such that the output at b is less than all the other outputs in that open interval. So if we look at what we were just discussing, this is the same function. Here we have a relative maximum at the turning point of -1. So I'm going to say at x equals -1. It's that maximum point there before it makes the turn. And then you have a relative minimum at x equals +1. So that's the turning point, and it's the lowest point in this interval.